Yeah, and so actually I found out, I think we missed out something here. This kt, when we factorize v out, we will still have the homogeneous solution here times UHT. Alright, so this still looks a bit messy. How can we trim this down? So the next thing we can do, well, we note, let's take a look at this messy term in the brackets here. So let's consider the messy term in this bracket. Okay, just gonna highlight it slowly. Okay, it's a bit troublesome. Okay, that's how we do it. Consider this term. Now what does this look like to you? Well, let's compare to the original ODE that we have. Okay, this is the original ODE, and if we just consider the homogeneous part, u prime plus kt u equals 0. So this is what the homogeneous ODE looks like. And take a look at how this and this compare. So I'm just going to copy them and put them side by side. Okay. Or rather, I'm just going to put it. Yeah, let's put it on the top and bottom. Can we see that it's exactly the same? U prime into kt into plus kt into u. This is the homogeneous part, and that's equals to 0. And then we have u prime, uh prime. This is the homogeneous differential, kt into u homogeneous. So since this is the homogeneous equation, this and this collection of terms here is exactly equal to the left hand side. And since it's exactly equal to the left hand side, this whole thing is equals to 0, which is very convenient for us. Okay, so then since this is 0, we can just cancel. The terms on the left, and we are left with this. And now we'll finally see the light at the end of the tunnel. So we have this v prime t. We finally know what our v prime t is. Okay, just going to bring this over to the left hand side, and voila, all we need to do is just integrate. Okay, alright, let's integrate respect to t, and that's it. So provided that we have already solved for the homogeneous part, and then now we can solve for the particular solution as well, we can find the v of t, and if we can find v of t, we can find the particular solution, and that is equals to this whole thing here, v of t times u h of t. So provided we can evaluate this integral pretty okay, we should not have a problem finding this up of t. So let's consider the tough question, or the tough looking question we were having just now. We have this. So I just came up with some random ordinary differential equation. It's the first order one. Okay, so what is next? What is next is that, well, we already find the homogeneous solution. So the homogeneous part, okay, yeah, example problem. So the homogeneous part, So what's the homogeneous part? Homogeneous part is what we discovered earlier. Sum a times b times exponential. This one I'll just call it k1, just for the sake of convenience. That's just some arbitrary constant. You can deal with that later. So now that we have this, all we need to do is find the up of t. Okay, the up of t is equals to, okay, the up of t is equals to uh of t, so that we'll copy this whole thing, put it at the bottom here, and what next? We need to copy the left hand side or right hand side. So this is what we copy, and then we'll copy this whole thing and we put it here. Paste. Now, at least in theory, as long as we are able to integrate this, the solution, the homogeneous solution, the particular solution should be possible to find. Only thing is that it looks like this, trying to integrate this seems like a challenge. So let's put this here. We'll get 1 over k1 on the outside. Okay, 1 over k1 on the outside. Then we will have this. Alright, I'm just going to delete the denominator. Make it look slightly less scary. Okay. And then as we notice, the k1s actually cancel out. So this k1 and this k1 cancel out. Okay, so we don't need to worry about what k1 is anymore. Okay, let me do it this way. Alright. And then what is next? We can combine these two terms. So the 5t, exponential 5t, times this exponential, that is just adding 5t to here, or 5t to this expression here. I'm going to take the 5t out, and I'm just going to put a 6t here. And then this is the what we are left with. And then the problem now is to integrate this expression at least. It seems difficult, at least for now, but we can do numerical integration or whatever. But the analytical solution I will not be discussing. We can always look at Wolfram to see what it has to say. So let's go to Wolfram. I'm doing it the lazy way. So integrate exponential of t cubed divided by 3 plus t squared plus 6t. And let it do it for us. I'm not going to go through all the steps. Okay. What we find is that there's no result found in terms of standard mathematical functions, but we do have a Taylor series. Okay, so at least in theory we will have something to write down on that piece of paper. Okay, so let's just copy this Taylor series down. Okay, we copy this Taylor series down, and as long as we have this Taylor series to help us, approximate some sort of solution. That will be sufficient for, you know, purpose of explaining this concept. Okay, so t plus 3t squared, okay, t squared plus 19 over 3 t cubed plus dot dot dot. Alright, so this is the particular solution, and we have a homogeneous solution as well. Okay, yeah, so pretty much that's about it. Yeah, for exploring variation of parameters, at least for the first order ODEs, we find that as long for first order ODE, as long as we have some homogeneous solution UH of t, okay, so if you want to solve, as long as we have some UH of t which satisfies, okay, so this is the homogeneous part, so this is what we've just derived. When it satisfies this homogeneous part of the equation, then UP of t is the integral of pt over UH of t times UH of t. Well, there'll always be this integral. We are guaranteed a particular solution as long as we can, you know, evaluate this integral. The only problem, of course, is to evaluate this integral, which seems pretty challenging. But that's what variation of parameters is about. Seems like it's a more solid solution, and you're always guaranteed something rather than, you know, having to do guesswork all the time. Okay, so the full solution u of t equals to c1 UH t plus c2 u p of t. So that's all I have. Thanks for watching. I appreciate it. I'll see you guys next time. Bye bye.